Hi, welcome to the exciting and detailed explanations of number system. So let's start.
Welcome back, Focus learners. Okay, today we're cracking open the ultimate insider's guide to mastering ninth grade math exams. We aren't just here to barely pass. We're setting a high-energy target right from the jump, and that target is a perfect 100 out of 100. We're going to completely demystify the number system, turning complex math into predictable, totally solvable puzzles. So grab your notebooks and let's get to work. All right, here's our game plan to conquer today's mathematical boss battles. First up, top-tier exam study hacks. Then we'll decode the number system, master the P over Q form, dive into the art of rationalization, and finally, conquer those exponent laws. Section 1. Top-tier exam study hacks. Think of these as your digital weapons for maximum efficiency. Okay, so before we even look at a single math equation, we've got to optimize exactly how we study. Because working harder is great, but working smarter, that's your ticket to a perfect score. So let me ask you this directly. Want to master math in half the time? I know. It sounds like a total clickbait question, right? But it actually just requires a massive shift in your current study habits. You have to take control of how you consume information. Here are your absolute must-use digital weapons. First, whenever you're watching an explainer, bump that playback speed up. Go to 1.5x or even 1.75x speed. Trust me, your brain can process info way faster than people naturally talk, and this literally saves you hours of precious study time. But, and this is the absolute kicker, when a question pops up, hit pause. You must attempt to solve the problem independently before you let the answer play. Seriously, active learning is what builds those permanent neural pathways in your brain. Passive watching, it's just a trap. It gives you this false illusion of competence. Actually, there's this golden rule from top educators that I really want you to burn into your memory. It goes, try it yourself, pause the explainer, and solve. If you can't, look at the solution later, but try first. This is hands down the single most important habit you can build to guarantee maximum mathematical retention. Don't just sit back and let me do all the heavy lifting for you.
Moving right along to Section 2, decoding the number system, real numbers and their decimal identities.
So to beat the game, you gotta know the players, right? Let's kick things off with a classic rational number. By definition, a rational number is literally any number you can neatly pack into the form of a fraction, P over Q. The only strict rules here, both P and Q absolutely must be integers, so whole numbers, positive or negative. Oh, and Q, our denominator, absolutely cannot be 0. You literally can't divide by 0. It just breaks the mathematical universe. No exceptions.
Now check this out. It's super interesting how clearly we can contrast the decimal behaviors of rational versus irrational numbers here. When you convert a rational fraction into a decimal, it does one of two things. It either terminates, meaning it just stops cold, like 0.5, or it's non-terminating but it repeats perfectly, like 0.333 forever. But on the flip side, an irrational number, it totally goes rogue. Its decimal expansion is non-terminating and non-repeating. It just stretches on infinitely with absolutely zero predictable pattern whatsoever. Think of pi, or the square root of 2.
Okay, Section 3, mastering the P/Q form, converting repeating decimals into fractions. So repeating decimals are basically just rational numbers in disguise. And here's your foolproof 4-step algebraic method to rip off their masks and convert them back into fractions. Step 1, let x equal your repeating decimal. Simple enough. Step 2, check how many digits are actually repeating. If it's just 1, multiply both sides by 10. If it's 2 digits, multiply by 100, and so on. Step 3, subtract your very first equation from this new multiplied equation. This is the absolute magic moment where that infinite repeating tail completely cancels itself out. And finally, step 4, just solve for x. All right, it's time to bust out that new study hack. Literally, right now, pause the explainer, grab your pen and convert this repeating decimal, 0.383838, into its P over Q fraction form, using those 4 steps we just talked about. Come on, try it yourself first. Okay, so the answer is 38 over 99. Huge congrats if you nailed that one. If you didn't quite get it, no sweat. Let's do a super quick mental recap. We let x equal 0.3838, so on. Since 2 digits are repeating, we multiply by 100, right? That gave us 100x equals 38.3838, so on. When we subtracted the original x, boom, those infinite tails just vanished completely. That left us with exactly 99x equals 38. Divide both sides by 99, and there's your fraction. Pretty cool, right? Next up, Section 4, The art of rationalization, defeating irrational denominators.
So in math, leaving an irrational number, like a square root, stuck at the bottom of a fraction is, well, it's basically considered terrible manners. So here are your rules of engagement to defeat them. First, spot that irrational denominator. Then, you're going to multiply both the top and the bottom of your fraction by something called the conjugate. The conjugate is just the exact same denominator, but you flip the middle sign. Why do we do this? Because it perfectly sets up this beautiful algebraic identity. A minus b times a plus b equals a squared minus b squared. Squaring the terms forces those stubborn roots to just disappear entirely, leaving you with a nice, clean, rational integer on the bottom.
Okay, you know what time it is. The crucial point here is actually applying it. Pause the explainer right now and solve this problem on your own. Rationalize 1 over 7 minus 4 root 3. Remember, find your conjugate and use that algebraic identity. Go for it.
Let's break this solution down step by step together. The conjugate of 7 minus 4 root 3 is obviously 7 plus 4 root 3, so we multiply the top and bottom by that conjugate. Our denominator instantly transforms into a squared minus b squared, which is 7 squared minus the quantity 4 root 3 squared. Now, let's crunch the numbers. 7 squared is 49. To square 4 root 3, you square the 4 to get 16, and square the root 3 to get 3. Multiply those, 16 times 3, and you get 48. So our whole messy denominator elegantly simplifies down to 49 minus 48, which is exactly 1. And that leaves us with our final answer, 7 plus 4 root 3. I mean, look at how much cleaner and more elegant that expression looks without a complicated root trapped downstairs. That is the true superpower of rationalization. All right, we've made it. Section 5, Conquering Exponent Laws, the final boss battle.
Okay, here is your ultimate, undisputed cheat sheet for exponents. This is where everything we've talked about really comes together to let us crush complex equations. Seriously, take a screenshot of this right now for quick revision later. Just remember the core rules. When you multiply numbers with the same base, you add the powers. When you take a power of a power, you multiply them. And a negative exponent, it just flips the number right into the denominator, taking its reciprocal.
All right, here is your final, most intense challenge. I need you to find the value of x in this equation. 2 to the power of x minus 7 times 5 to the power of x minus 4 equals 1250. Pause the explainer right now. And hey, here's a massive hint. Take that giant number, 1250, and break it down with prime factorization first. Then just compare the bases on both sides. Good luck, you got this. Okay, let's unpack the logic here. A number like 1250 looks totally terrifying until you prime factorize it, right? If you divide it by 2, you get 625. Divide that by 5 a few times, and you'll find that 1250 is exactly 2 to the power of 1 multiplied by 5 to the power of 4. Now check out our equation. We've got bases of 2 and 5 on the left and bases of 2 and 5 on the right. Because the bases match, their exponents literally have to be equal. So first, you can equate the powers of base 2, giving you x minus 7 equals 1. Or, conversely, you can equate the powers of base 5, which gives you x minus 4 equals 4. And guess what? Either way you calculate it, the final variable value is revealed, x equals 8. Breaking down that scary large number made comparing the exponents incredibly simple. It's like a giant puzzle just clicking perfectly into place. Okay, let's quickly recap everything we've conquered today. If you want that perfect 100 out of 100, you gotta combine ruthless study efficiency with clear mathematical logic. Speed up your video playback to save time. Force yourself to pause and solve before looking at answers. That is how you build real, permanent mastery. Make sure you can instantly spot a rational versus an irrational decimal. Own those step-by-step methods for P over Q conversions. Clear out those messy, irrational denominators with rationalization, and break numbers down to conquer your exponent laws. You are now fully armed with the ultimate toolkit for the number system. But listen, the real magic only happens if you carry these habits forward. So, I'm leaving you with this. Are you ready to apply the pause and solve hack to your very next study session? Take control of your learning, keep pushing those limits, and I'll catch you in the next explainer.
Thanks for watching. Until next time, stay safe, stay healthy.